Okay, hello everybody. Welcome back. This is example 12 and it is on page number 6. So we're going to do 11 and 12. Hopefully you've already done 11. If you didn't, go back and find the example 11 because I'm going to go a little slower in that one, a little bit faster with this one because hopefully you've already seen it before a couple times now. All right, let's get going. We're going to always start compound interest problems with our variables. I know I just did the variables in a different order. I apologize, but whatever you get, FP and RT, doesn't matter really the order. It just matters that you have all 5 there. Okay, this example says that if you deposit $8,000 into an account paying 7% interest, so we're going to go 0.07 there, compounded quarterly, so we've got, get rid of that. It's not supposed to be a decimal point there, just a 4, good. Okay, so annual interest rate compounded quarterly, how long until there is $12,400 in the account? So I wrote down the final value of $12,400, initial value of $8,000, and we're trying to solve for T. So just like we did last time, I'm going to write down the quadratic. Jesus, what time is it? It's 4:03. Been a long day. Not quadratic formula. You're going to write down the compound interest formula. So that's F equals P times 1 plus R over N, all to the NT power. So I'm going to start replacing my variables with actual values. 1 plus 0.07 divided by 4. And then NT is going to be N is 4, T is our variable of question. So that's going to say to the 4T power. So 2 steps here. We got to clean it up and we got to divide by P. So let's figure out what our parenthesis value is there. We have 0.07. Start on the inside, right at the rate, divide it by N, and then add 1 after you've calculated that division. So notice I'm going to divide 0.07 by 4. I'm going to press enter, and now I'm going to add 1 so that my parenthesis value is 1.0175. So that's going to go in the parentheses. My other step here is going to be to divide out P. We get the 8,000, and we say 12,400 divided by 8,000. And we get 1.55. So from there, we know that the 8,000s are gone because we divided them. And we know that the inside value is going to be 1.0175. So 1.0175 raised to the 4T power. Now, we're back in that same position where we have an answer, we have a base, and we have an exponent. So very briefly, I'm going to rewrite this in variable terms. Okay, we have a base raised to x equals an answer. And the way that we rewrite that with a logarithm is to say log base answer equals the exponent. Okay, so the log, the base, 1.0175, and then the answer is right over here. So we've got the base, we've got the answer, and we need the exponent. So whatever that power was, that is now all by its lonesome over on the right. So 1.0175, and the answer was 1.55. Now we're going to go back to the logarithm calculator. So let's get out of here. Go back to logarithm calculator. And we said that the base was 1.0175. And then we put in 1.55. And we're going to hit calculate. So we get that answer right there of 25.26. 25.261632785. I know I'm crazy for writing that, but I like you to see exactly what the calculator spit out, and then you can adjust it afterwards. So we're back here. Actually, I'm going to stay in this mode right here. There we go. So we know 25 was the value of that logarithm right there. But that 25 is 4 times the year value that we're looking for, because that's 4 times the t value. We're going to undo that multiplication with division, and I'll divide it by 4. You can use your old regular old calculator for that part. 261632785 divided by 4. And we're getting a number, sorry, that wasn't in the screen, 6.315. So 6.315408 equals t. And then we always round to 3 decimal places, so I'm going to look at that 315. The 4 would be rounding regular, so we're at 6.315 years. Okay, so that is example number 12, and I think I'll just record example 13 as well for all of you. Okay, so let me go stop this, and I'll see you for the last example.